So before we looked into like the static representations, now let's look at interaction. There's different types of interaction. So one is to, well, you can select certain data points, you can navigate. So basically where the data points don't change, but you navigate within the visual, like panning and zooming. You can rearrange your data. So there you do change the data points, so where they lie on your screen. You can change the visual encoding. So for example, yeah, small things like change the transparency of an image, or switch from a linear to a radial layout, as we saw in one of the earlier sessions on high dimensional data. We can filter data, or we can aggregate, basically changing the granularity of your visual elements. So basically summarizing, right? So again, these are some of those. This in particular I want to mention, the change of view over time. Yeah, so we have animated, let's zoom in, voila. Remember, well, in the earlier sessions, I told you that animation does not work, right? So like I said, if you have data changes over time, and in many cases, not always, right? But in many cases, it's very difficult to actually see to get an idea of what's going on if you animate things. Let's say you have a network that changes over time, like links appear, links disappear in that network, node link diagram. It's very difficult to compare 2 points in time, right? But if you have 2 time points, right? You have a time point and then a different time point where the points are a different location. It does make sense that it does make a lot of sense to have a transition, an animated transition between the two, right? So this point was here, right? It was over there, and then it moves down, so that you actually see how things are related to each other. If you have this and you show the other picture, it's very well. You cannot see which point corresponds to which one. Remember the exercise that we did with the change blindness? So where we had that airplane with the engine that appears and disappears, that's what this is. So you want to have a transition between the two. Yeah, to combine visuals, there's many different things to combine visuals, but the most, well, a very strong one is what we call small multiples. What is a small multiple? It's basically taking your visual and making different versions of it next to each other, right? So here we have a data set with 3 dimensions. So we have X and Y, and we have color, right? Color, because there's certain categories. There's let me quickly. There's 5 categories, right? And color is the best for categories if position is not available. So this is a quote unquote good data visualization. But right, still it's very hard to see things. I told you before that you can use position twice, right? So there's an X and a Y, but actually you can use it more than those. You can use it 4 times, because you can embed within X or Y. You can embed again, right? So here we have X and Y, right? But we use the X-axis again to show different categories, right? So we have, so we can use the position 4 times instead of 2. So here we use position for numerical data, right? A numerical dimension. We use the Y position for another numerical feature, and we use the X position for a categorical feature. Okay, and this is really strong because here you can see here we have in color the color of the that corresponds to the color used here, right? That the green category has like a positive correlation between the data points. The yellow has a negative correlation. That's impossible to see here. Well, once you know, you could think, well, yeah, maybe there's like a yellow and a green, but it's very hard to see. It's very easy to see here, right? Something else, well, there's only one purple. Actually, the purple is, yeah, within this explanation, the purple is shown in all 5 of them, but there's only one purple point, right? There's no correlation here, and there's some strange shape in the blue data, which is not clear here either, right? So small multiples work really, really well, and they're very scalable, right? So actually you can make them quite small. What is important though is, as you see here, all these lighter points, right? Like all the light points here, these are all the points that are not blue. Here's all the points that are not green. And I think we covered this before, or maybe this, wait, let me check. Maybe this, no, we covered this before. The focus and context. So the focus here is on the blue category of the data points, but the context of the other data points still needs to be there, right? Otherwise you have no idea how does this fit within the whole, right? So you do need to have like the other points faded out or smaller in some way, not drawing attention, but still showing the background, okay? So small multiples, important to remember. We can superimpose things, so putting things on top of each other or embed them. For example, if you have a network and a map, so you might have like networks within a map, or you might have maps within a network, which is not the same thing. So one of them here, the base is the map, here the base is a network. Yeah, so I mentioned small multiples. Oh, yeah, right, linked highlighting. So this is an important one. Where basically we have, yeah, what we call linking and brushing. So where we have certain, let's look at this one. So let's say we have 3 dimensions, right? X, Y, and Z. And here we plot X versus Y. And here we plot X versus Z, right? Actually, that's cannot be correct here. But anyway, let's say we have X, Y, U, and V, right? So we plot X versus Y and U versus V here. And what linking and brushing does is if you select certain data points here, right? The same data points are in here as well, right? Because it's the same points, just different dimensions. So if you select data points here, that they are highlighted in the other one. And that is a very, very strong way of actually exploring data. That's very, very strong. I mentioned small multiples. Yeah, sometimes we want to reduce our items and attributes as well. There's different ways of doing this. So we may, for example, filter. So instead of using all the items, we just select a certain number of items and just discard the rest. The same thing we can do with attributes. So we select certain dimensions, we just do not show them all. Something else we can do is we can aggregate. So for example, if you look at the item, the number of items, basically what we do is clustering, right? So here these 2 are clustered into one cluster, these 2 are clustered into one cluster. A box plot is an example of that. Or we could do dimensionality reduction, where we basically combine different dimensions into one. So this is where clustering and dimensionality reduction comes in. And then introduce new things, but I will not go into